Okay, welcome. This is the week 6 webinar for the online stats class. And let me go over what we're going to be talking about today. So first thing, as always, I'll answer any questions if you have them. And then today is actually like a really important day because it's the beginning of truly using this stuff. Okay, so we talked about the normal distribution and the central limit theorem, but now we're actually going to be just focusing on using. Okay, so what we're going to be looking at, we're going to look at confidence intervals for means. It turns out to be a very, very important piece that is done. Then we'll look about confidence intervals for proportions. And that's going to be a big theme in this class is we'll, have something we do and we'll see if you do it for means, you use this method. And if you do it for proportions, then it's the other calculator or whatever you're going to do. And the words are going to be a little different. So that's going to be typical. Then we're going to look at sample sizes for means. So if you want to do a study and have, a good results, as in results that tell you something, how big a sample size do you need to do? And remember, the bigger the sample size, more work you have to do. So it's always easier to have a smaller sample size, but if you have a small sample size and you have worthless results, then you wasted your time. So it's a kind of a give and take on how big a sample size. You want really big, but you don't want really big. You want small, but you don't want small. So we'll talk about how do you decide how big is the right size for your sample size. And then finally, we'll get into sample sizes for proportions. Same idea, but for the yes/no question. So just a reminder, this is week 6. And 6 is an even number. Why is that important?
Exam.
You're welcome to put in the chat box or say it. It's even. And why is even important? Exam.
E-A-N-N-M, exam.
Yep. Yeah. So we have the exam. So there's a week 6 exam this week. And I want to remind you, because now it's going to become more and more, is that the first part, like half of the exam or so, covers week 1, 2, 3, and 4. And the last half covers 5 and 6. So pretty much the last half will always cover the newest 2 weeks, and the first half will cover the older weeks. And there will be kind of word problems where you have to write a sentence to your answer, or sometimes several sentences, and those I grade. And those are going to be the week 5 and 6. Remember, 5 was central limit theorem, and 6 is going to be confidence intervals. So any questions about anything? Okay, I do want to mention something is that as I mentioned last week, I had a conference last week. So I was literally in Southern California between I left kind of left Tahoe on Tuesday afternoon, and I didn't get back to Tahoe until Sunday night. So I have been super busy with not much time to do things. So I did not do any I did not post any grades today. So for your discussion assignment that happened last week, that'll be posting tomorrow. And for the projects, so maybe all of them will be tomorrow. It depends how long it takes. But I'll post tomorrow. It might be tomorrow and Wednesday, maybe tomorrow, Wednesday, and Thursday, because the projects take a while to read. I do want to mention something about the projects because I did look a little bit at least. And that is, for those of you who are listening to this, and hopefully everybody, but I know not everyone listens, it is an absolute requirement to have a partner, or even better is 2 partners, so a group of 3 in your project. Okay, so those of you who submitted the project and all you had is your name on it and it was your project, almost all of you will not pass because there's an immediate 25% deduction from your grade which means you have to get, a 95% or higher to even pass the project. And that 95% is hard. So don't do the project alone. And project 2, it's the same rules. You must have partners. So make sure that happens. I know some of you had partners, but many of you didn't, and that's not good. And I'm hoping in the webinars I was very clear. It's also on the syllabus about partners were an absolute requirement for the projects. Okay, and that's true of project 2 also. So I do want to make that as a big note because it happened more than it's ever happened in my career of teaching. And we're talking 28 years where I do project-based, partner-based projects. So get partners. It's really important. Okay. Let us talk about confidence intervals for means. Okay. So the idea here is you do a survey and you get some proportion or some mean, and you have to decide how reliable that result is. Because when you do a survey, you can't ask, and let's say you do a survey of all people in America, you can't ask everyone. So you're only going to ask a small percent of the population compared to the whole population. So then the question is, are you likely to be far off or not so far off? And what is the interval of values at which you're likely to have the population mean, which you don't know, within that interval? And that's what this confidence intervals are all about. So I think I need to do the second one because we don't have too many people here. So the question I have for you is how far in miles, how many miles? Maybe I'll write that down. How many miles do you live from 3 of your friends? So let's see if you can put in the chat box how many miles. Just pick 3 random friends that you've got. Think about how many miles. You don't have to get exactly how many miles, but approximately. And how many miles each of those people live from you. And let's see if you can put that in the chat box. Okay. And again, you can guess. You probably have a somewhat idea. And let's see, just grab 3 friends, think about 3 friends, and type in the number of miles that the first friend lives from you, comma, the second friend lives from you, comma, the third. Okay, so what I've got is 2, 5, 7. Okay, and those are 3 of your friends. Okay, and actually that should be up here. 2, 5, 7. And what we want to do is we can now calculate the sample statistics. So X bar, okay, that one I can do in my head, but I'm going to not do it in my head. I'm going to do it using one variable statistics calculator, which will happen in a minute. 2, 5, 7. And this is a sample. So I'm going to go sample, standard deviation, and you calculate. And the mean is 4.666666. How about 4.67? So that's X bar because it's a sample mean. The sample standard deviation is about 2.52. I'm going to go 2 decimals. N is the sample size. That was 3. Any questions so far? Okay, SE stands for the standard error, which is not the same as the standard deviation. That's the standard error, and the standard error is approximately 2.52. And according to the central limit theorem, divided by the square root of what number? Do you remember? Remember what the standard error is? It'll be 2.52 divided by the square root of, not the square root of standard deviation, it's the square root of the sample size, which is 3. Is that clear? Yeah, it's the square root of n, and n is 3. So 2.52 over root 3. So let's do that. 2.52 divided by, and we're going to do the square root of 3. And you get about 1.45. Any questions so far? Any questions? Okay, this is review because we've done this before. This was, again, this whole S over root n, that was the central limit theorem. It really is sigma over root n, so I'm going to use S as an approximation for sigma because we don't know exactly what sigma is. And we're going to talk about how we're going to deal with that approximation in a little bit. Any questions so far? Okay, so now again, let's continue thinking about last week, which was the central limit theorem. And I'm going to have to make this assumption, which is a poor assumption. And that is that the distance that you live from all your friends, I'm going to assume you have hundreds of friends because you're a really great person. And you must have lots of friends. So, but you only chose 3 of them. Okay, we're going to assume that was random. And we're going to assume the distribution of your friends' miles from how many miles they live from where you are is normal. We need to make that assumption, and we really can't do much of anything when you have a sample size of 3. Okay, and that's a terrible assumption, but if I asked you to do that for your 31 closest friends, then you wouldn't have to assume it's normal, but that would take all day. So because of that, I can write this normal curve. So I have this normal curve, just like that. And what we're going to be looking at is we're going to say, what do you think the population mean distance your friends live from you is? So in other words, you had a sample, small sample size, but you had a sample, and you want to use that sample to predict the population. Now, if there's no bias, your best prediction will be 4.67 miles. Is that clear? So if you randomly sampled, your best prediction would be 4.67, because that's what it means to have an unbiased estimator. So that means on this normal curve, I can put 4.67 for this X bar. Any questions on that? Then what we're going to do is we're going to say, well, what if we want to have a 95% probability that your guess of this 4.67 is correct, in that there's going to be an interval where 4.67 is right in between, such that there's a 95% chance the population mean distance from your friends to you is going to be in that interval. Any questions on that idea? So in this picture, I'm going to take this interval from here to here. We're going to call that x minus e to x plus b. E will be that interval because you're going to start at x bar, you're going to go left by some error and right by some error, and you're going to say, well, the population mean is likely to be within E of X bar. And that means go left and right by that E. Any questions on that? Any questions? Okay. It turns out that the standard reliability that researchers and news and most people and groups use is 95% reliability. And we're going to call that a 95% confidence interval. Okay, so you want me to repeat how I got this, what this picture is showing? Okay, so our X bar, that was this 4.67. That was the average of your three friends' distance. Is that clear? So that's right in the middle of the normal curve. Okay, then we're going to say we want to go left and right from there. So there's a 95% chance that the population mean distance, not the sample mean, but the population mean is in that interval. Is that clear? And that interval will be called the 95% confidence interval, because there's a 95% chance of the population mean being with the interval. Let me tell you why it was chosen. This was done like 80 years ago or something like that. Might have been 90 years ago. Before internet or anything like that. And it was news, but believe it or not. And the big news company of those days was New York Times. And they decided that they would be okay if they made the predictions correctly 95% of the time and were wrong 5% of the time. Okay, does that make sense? So that's why they chose this 95%. And once they chose it, because they were, in charge of they were the ones everyone listened to, then that's what everyone used. So 95% is kind of the standard percent that people are okay with being right 95% of the time and wrong 5% of the time. Does that make sense? And if you're a news company, if you're wrong a high percent of the time, no, everyone's going to say, well, you suck. I'm not going to listen to your news. I don't trust you. Does that make sense? So, but if you're right 95% of the time, that's probably enough. If you're wrong once in a while, that's okay. Any questions on that? Okay, just a note, this 2.52 is not sigma. It turns out it was S. It's not the population, which means this isn't quite a normal curve, it turns out, because we don't know the true population standard deviation. And this also happened a long time ago, that it turned out, it was kind of one of my favorite stories. It was all about beer, whether you like beer or not. There was a guy who happened to be a statistics professor, and he worked at a brewery researching beer on, how good the beer was, how much people liked it, all kinds of things like that. And what he realized was that when he used the normal distribution with a 95% confidence interval, he wasn't getting it right 95% of the time. So something must have been wrong. And he realized the reason is he didn't know sigma, he only used S. And this person decided and created a new formula, which is way too hard for this class, but not too hard to trust the calculator, and named it after his students and called it the student's t-distribution. And it looks somewhat similar to the normal distribution, but it's a student's t-distribution. Okay, so when you're not knowing the standard deviation, which is almost always the case when we're talking about means, then you use the student's t-distribution instead. Okay. Any questions so far? All right. And what we're going to do is we're going to find the interval so that if I go left and if I go from that left side to the right side and I look at the area under this student's t-distribution curve, it'll be 95% or 0.95. Does that make sense? And the good news is the math is really hard. Why is that good news? Any guess? Fun? I don't know about fun. No, it means that it's so hard, I can't ask you to do it. So this is where you have to trust me. Do you trust me on the math? Yeah, fun puzzle. No, unless you want to get a master's degree in math, or a PhD, but master's is probably good enough. Then you just trust me. So I'm going to go back to the calculator menu. And what I'm going to do is I'm going to go to any guess on what we're going to do. Which one? Yes. Number 8, not normal probability. First thing is not normal because that would be we're using the student's t-distribution, which is like really hard and way harder than normal. Idea? And we did that. Already done that one. It's the next one. Okay. Actually, I'm going to do the confidence interval. You could do actually 9 or 10. I'm going to do number 10 because really data is what I've got. Confidence interval for a mean with data. Okay, because we want a confidence interval. Is that clear? And it says type in the values of the data separated by commas. For example, 2 comma 4 comma 5 comma 8 comma 11 comma 2. Then type in the confidence level, CL, and hit calculate. Right? The confidence level is a decimal. For example, 95% is 0.95. So the data was, if you remember, 2 comma 5 comma 7. So I type in 2 comma 5 comma 7. The confidence level is 0.95. Any questions? I tried to make this calculator pretty easy to use. Hopefully you agree. And I hit calculate. Okay. Any questions on that? All right. Now, what we get in this case is a lower bound of negative 1.6 and an upper bound of 10.9. Okay. It's a really wide confidence interval. Any guess on why it's so wide? Pretty useless information, it turns out. You guess? Let's see, guessing. Okay, the reason is the sample size was 3. You should never, ever use a sample size of 3 if you want any information that is meaningful and useful. Is that clear? Okay, so I did a sample size of 3 because I didn't want to spend all day typing, wasting your time. But if you do anything that you need, then a 3 should never be your sample size. Okay, first thing, you should have over 30 just for that normal distribution thing, but also sometimes even bigger. So our lower bound was negative 1.6, our upper bound was 10.9. Okay, and negative 1.6 is kind of silly anyway, because we're talking about distance someone lives to you, and you can't live negative 1.6 miles from someone. Okay. So now we can interpret the confidence interval. Okay, and it's very important you understand the words and you get the wording right. So I want to note this first word because that'll get you started with. Whenever I ask you to interpret the confidence interval, you are going to be required, maybe I'll put that in red to really see it, to start with the word with. And that'll get you started. And if you don't do with, then I'll take off points. Okay, and you're hearing it in the webinar now, so you know it. And I hope everyone's watching this webinar and actually paying attention. So, want to get it right, you should have with. With 95% confidence, we can conclude that the population mean, I'm going to write distance, that friends are, or friends live from a person, is between technically negative 1.6, but you can't be negative, so I'm going to say 0 miles and 10.9 miles. Away. By the way, can 0 miles happen? Yeah, absolutely. What do you call that person? Don't see jumping in. Calm. You call him your roommate, right? I don't know if you have a roommate, but when I was in college, I had roommates and they were friends and they lived 0 miles from me. Okay, so that can happen, but negative 1.6 can't. That's why I just moved it to 0. Okay, usually you're not going to get negative numbers, but in this case we did because that's just what happened. Okay, any questions? Any questions on this example? And I want to note that you must refer to the population mean because the confidence interval is all about the population mean, not the sample mean. Got it? If you do not have that word population, I will take off points. Okay? And that includes the discussion posts and the exam, by the way. Okay? Any questions on that so far? All right. And the word mean is only used when you have quantitative data, when you're talking about a mean. If you had a yes/no question, you don't use the word mean. So that's just a note. All right. So the next thing is, what does it mean to be 95% confident? Okay. So what is that? And sometimes we'll say this, interpret the confidence level. So there's that picture. So remember that 95% is the area between here and here, or the percent chance that the population mean is in that group. Another way of thinking about it is thinking about the news agency. News agency wants to show that if they do a lot of news stuff that involves statistics, and they talk about the confidence interval, then they want to make sure that 95% of the time, that interval they give is going to contain the population mean. Do you see that? So here's how you interpret it. Okay. You say if many samples of size 3 are taken, so think about like the news company doing this over and over and over again, okay, thousands of times, then each one will result in a different confidence interval. Because if I asked you how far away 3 different friends are, you give me different numbers probably, right? Do you agree? Okay, you give me different numbers. And if I asked you a third time, you give me different numbers. And I could ask you all day long and you give me different numbers. Each time you can do the computation and get a different confidence interval because you can have different 3 numbers. Does that make sense? 95% of these confidence intervals will contain the true population mean. Okay, in this case, the mean distance. that friends live from you. The other 5% will not contain the true population mean distance that friends live from you. Any questions on that? Okay, I strongly suggest you write this down because this is really hard. It's a lot of writing. And I want to give you a big warning. From now on in this entire class, there's going to be a lot of writing. Okay, and a lot of typing on the exams and that kind of stuff because you're going to have to type these paragraphs. There's no short way of doing it. Any questions? Okay, let me scroll down. So here's what I made as a template. With whatever percent confidence, it'll often be 95%, but it doesn't have to be 95%, but it'll often be. It can be concluded the population mean, whatever it is between that and that. Okay, that's the conclusion template. The interpretation template is if many samples of however we had, in this case we had 3, are taken, then each would produce its own confidence interval. Whatever percent, like 95% of these confidence intervals will contain the true population mean of whatever you're talking about. And whatever percent, that'll be 100% minus 95%, won't contain the true population mean of what you're talking about. And that's a template. Do not leave the XXX as XXXX. Make sure you put in the right thing in there. So when I have a template, that means those X's need to be replaced with the context of whatever you're doing. Any questions on that? Any questions? Okay. Again, it's much easier to watch me do it than to do it yourself. So I strongly recommend practicing. And when you're doing the homework, I strongly recommend not just clicking on the multiple choice on which is the right one, but actually before you even look at the choices, write it down and then go click on the multiple choice that's the right one for the chapter assignments. Does that make sense? And then you'll get ready for the exam. Because on the exam, you're going to have to, at least for the last couple questions, you're going to have to do this. Okay. And just a note, still using the central limit theorem, you need a sample size over 30. Otherwise, you can't really do anything. Okay, otherwise you have to assume you have a normal distribution. And realistically, assuming you have a normal distribution is not a good thing. Okay, I don't know if you've ever heard this before, but when you have a normal distribution, the word assume, how do you spell the word assume? What's the first 3 letters? Yep. And that's what you make of you and me. Because the last 3 letters are U, M, E. You and me. So assuming is a bad thing. You don't want to have to do that in the real world. Okay, sometimes you have to. And I'll ask you, do you need to assume? And if the sample size is, if it's a quantitative survey and the sample size is 30 or fewer, you do need to assume. Remember in your project, I remember you had to have a sample size more than 30. That was the reason. Okay, and I told you before you even understood that stuff. Okay, so it's very important. All right, I figure next we'll get into kind of what's happening this month. What's the big holiday this month? Hopefully you know. Yeah, Halloween. Okay. So here's a question. How many adults do you think are going to celebrate Halloween? Or about what's the proportion of all Americans who are going to celebrate Halloween this month? Any guess? Any guess on the proportion of Americans that will celebrate Halloween? Okay. You probably may have no idea, right? Okay, think maybe 40%, maybe. But that's a total guess. What if you really wanted to find out? Okay, maybe you, again, owned a news company. You might own a news company and you want to find out the proportion, the population proportion of all Americans, of all adult Americans who are going to celebrate Halloween. What would you do? What would you do? And the answer is don't just guess. I'm not seeing you jump in. You do a survey. You would go and you would survey a whole bunch of Americans, however much time you had, and ask them, do you plan on celebrating Halloween this month? And if they say yes, you mark down yes. If they say no, you mark down no. Any questions on this? Okay. How is this different than the example we just did? There's a big difference. Yeah, it's a yes or no question. This is not a quantitative study. This is a yes or no survey question. So the question is, what percentage of all adult Americans will celebrate Halloween? We will never know the percent of all adult Americans that plan on celebrating Halloween. It's not possible to find that out. You'd have to survey every American adult. Good luck. Hundreds of millions of people to survey. Most are not going to answer your survey. It's not going to happen. So that's why you take a sample. So you can't get the exact percent of all adult Americans. But what you can do is you can take a sample and use that sample to make a good guess at the percent of all Americans who are planning on celebrating Halloween. Okay, do you think this was done? Do you think there was a sample taken? What do you think? Okay, the answer is yes. And I'm going to cite my source. So the National Retail Federation, NRF, conducted a survey. And they actually had a pretty large sample size. This is much larger than most people do. They had a sample size of 7,945 people in America. Okay, sounds like a lot, but remember, these are adults, and there's hundreds of millions of adults in America. Does that make sense? Do you know? I don't know if you know that, but there are. And do you think close to, less than 8,000 people is good enough to have a good estimate when you have hundreds of millions of people? Okay, the answer is yes. Even though it's a small percentage of all people in America or all adults in America, it's actually big enough. And we're going to see that in a bit. And in their survey, okay, and I read it. What I do is before the webinar, I try and think about what's big going on, and I try and I find something. And the good thing is I can always find something that's relevant to whatever's going on. Okay, and I figure Halloween is going on pretty soon. Okay, statistics is used everywhere, and confidence intervals especially is a biggie. So the proportion they got was 72%. So by the way, 40% way off in terms of what they got. But you guessed. Okay, but they actually did better than guessing. They did a very big survey. So what we're going to have to do is first we're going to have to see, can we use the calculator, which uses the t-distribution? And I'm not going to get into the details, but the t-distribution uses a normal distribution. It's very complicated. But what you have to know is a yes/no question, it's not about the sample size being bigger than 30. It's about the number of yes answers, which is NP, being bigger than 5, and the number of no answers, which is NQ sometimes, is also bigger than 5. If I take N times P, N was 7,945, and P was 0.72, and I got 5720. Okay, there were decimals, but you want to round to the nearest whole number on something like this because you can't ask like, 2/10 of a person. So they do rounding. So you should do, proper rounding. And that is much bigger than 5,720. And then number of no's, the easiest way I think to get the number of no's is you take the number of people they asked, 7,945, and subtract the number of yeses, and that'll give you the number of no's, which is 2,225. Any questions on that? Okay, and that also is much bigger than 5. So when NP and NQ are bigger than 5, that means that we don't have to make, that means that we can actually use the t distribution and the normal distribution, all that stuff, and do the calculation. Okay. Let's go and do it. Even though I did it here anyway. I'm going to go back to the calculator. And tell me which calculator I need to use. Which number? What calculator number do you think is the appropriate calculator? Not sure. Okay, we want a confidence interval. That's a hint. Yeah, number 12, because we have a proportion. Okay. And by the way, just to note, there's a sample size proportion. We'll get those later. But this is week 6. We're halfway through the class. And check it out. There's 25 calculators. We're at calculator number 13. So we're really halfway through the class. So I'm going to go confidence interval for proportion. And we got to fill in N. N was 7,945. X was 5720. X is the number of yes answers. 5720. And just a note, pretty much everyone uses 95% for anything that's social science. That 0.95. When do you think you would want to really be more confident to not be off and wrong? What kind of fields do you think would be more important to be like 99% confident? Yeah, medical. Okay. So for example, when they did the COVID testing, okay, when they tested the vaccination for COVID about 4 years ago, they had a much larger sample size so that they can have also a larger confidence level, like 0.99, because you don't want to be wrong. Does that make sense? When they did all the experimentation to decide whether it was safe to get the shot. And just a note, it's just a weird coincidence. I did not get the COVID shot today, but I got my flu shot today because I look at all the statistics and I know that if I get my flu shot, I have a smaller chance of getting the flu. Okay. And they do this right. They make sure that they do studies that have large sample sizes and they have a really good confidence level and a confidence interval so that, you don't have, 1 million people dying of whatever they're doing. Okay, so just let you know, I study this stuff. So you can do your own research and find out, but I did my research and I made sure that they did the studies right. Okay, so I hit calculate. And here we have it. The lower bound was about 0.71. The upper bound was about 0.73. Very important that you don't go 0.72. What's wrong with 0.72? What's wrong with saying, it's 0.72 for the upper bound? Yeah, we need to always do rules of rounding. This is 0.729. Okay, 0.7298 even. And the rules of rounding say 9 is 5 or bigger, which means you make that 2 a 3. It's very important to do rules of rounding or just all kinds of things go wrong. Okay, including your homework and the exams and all that. So if we want to go 2 decimals, because percent's good enough, 71% to 73%. Any questions on that? Okay, and by the way, there's a picture of this 95% confidence interval. So we have 0.71, 0.73, 0 actually, you can go 3 decimals if you wanted. And that gives you the picture. So our confidence interval, the lower bound is 0.71, the upper bound is 0.73. The margin of error, what you do, and you'll hear this word a lot, margin of error is how far away the bounds are from this proportion. And it could be mean also if you're talking about means. So notice p hat was 0.72. Okay, and the upper bound was 0.73. So I take 0.73 minus 0.72, and I get 0.01. So that we could say we have a 1% margin of error, which is a very small margin of error. Any questions on this? Okay, now we're going to interpret the confidence interval. Very similar, but we're now going to be talking about proportions and not means. So with 95% confident, notice same word with, we can conclude the population that has to be there, proportion of all adult Americans that will celebrate Halloween is between 0.71 and 0.73. Also, sometimes it's easier to talk about with percents. So you can also, this is really saying the same thing, with 95% confidence, we can conclude that between 71% and 73% of all adult Americans will celebrate Halloween. Any questions on that? Okay, what if we wanted to be 99% instead? Any guess what would happen to this interval? The 71 to 73? If we wanted to be really confident, like 99%, because I don't want to be wrong, what would happen? The key is it's actually not closer, farther, because if the area went from 99% to 95% to 99%, then this interval is going to have to get wider to give you more area. Do you see how that picture works? Because if you're at 95 and you want 99, you're going to have to go like that so that you can get more area. Does that make sense? So, in particular, let's take a look at it. It's really easy with this calculator, right? Just take the 0.95 and make it 0.99. Okay. Yeah, so The important thing is it's fine to look at it backwards before you even try anything. It's not fine to look at it backwards on the exam. So the key is, hopefully you get it now. That's the most important thing. Okay, notice now it's about 0.7069 to 0.7329. So that's wider. So the 3 decimal places is 0.707 to 733. And you could even go 0.999. You want to be super confident. And then you're going to be 0.70 to 0.74. Do you see? So it gets wider. What if you wanted a really good confidence level and you wanted a small margin of error? What would you have to do? So if you wanted to be closer or narrower and you wanted a large confidence interval, what would you have to do? Any thoughts? No, I'm saying if you wanted a bigger percent, if you wanted 99.9%, but you still wanted a small margin of error, what would you have to do? Should I tell you? You'd have to ask more people. You'd have to have a bigger sample size. So with a very large sample size, you could be very confident and have a small margin of error. But the problem with that, especially for this company, is it's expensive to survey all those people. You got to hire someone to survey the people. Does that make sense? And if you don't have a lot of people in your staff, it's going to take a long time, and it might take 2 months, and by then, no one cares because Halloween's over. So there's definitely issues. So it's a big, give and take on what you do. Okay, and I want to give you kind of a heads up, and I'll talk about this later, and later meaning in a week or two, a couple weeks, is that in your project, you're going to have to talk about all that stuff. Project 2. So we're not ready to completely talk about project 2, but I can give you hints. And a big part of project 2 will be confidence intervals. Okay, to interpret the confidence level, if many groups of 7,945 adult Americans are surveyed, then each group will result in its own confidence interval. Okay. Oops. It wants that. 95% of these confidence intervals will contain the true population proportion, not mean, but proportion this time, of all adult Americans that will celebrate Halloween. Any questions on that? Any questions? Okay, so then the last thing we're going to do, this isn't that hard a week, by the way, but it's a really important week, is we're going to talk about how big a sample size you need. And the central limit theorem said this standard error sigma sub x bar is sigma over root n. E turns out to be z times sigma over root n. And you can solve that and you get n equals z sigma over e quantity squared. Okay. So if you want a smaller e, that's in the denominator, you're going to have to increase the sample size. Does that make sense? Okay. And that's really important. Okay. In particular, if you wanted to cut your error in half, then what's a half squared? Because of the square. What's 1/2 squared? A little bit of basic math. What's 1/2 times 1/2? No, that's 1/2 plus 1/2. 1/2 times 1/2 is 1/4. And it's in the denominator, so the reciprocal of that is 4. So if you wanted to narrow your margin of error by a factor of 2, you have to increase your sample size by a factor of 4. Does that make sense? If you wanted to decrease your margin of error by a factor of 10, you'd have to increase your sample size by a factor of 100, because that's 10 squared. Any questions on that idea? A little bit of math, nothing too terrible. Okay, so now let's do an example. Okay. Suppose you wanted to find a 95% confidence interval for the population mean hourly wages of nurses in California. Okay. And again, I don't know the exact population mean hourly wages of nurses, but I did a little research and I found that they did a little study and the standard deviation was $25 an hour. If you want a margin of error to be no more than 50 cents, because most people don't mind too much, you're not going to like argue with your boss to get 50 cents an hour more if you're a nurse. Do you agree? It's probably not worth the argument. Okay, you want $5 an hour more, but not 50 cents. So if you want a margin of error of no more than 50 cents, because it's okay to be off by that much, how many nurses must you survey? Any questions on that idea? Okay, well, what do we have to do? Any guess? The easiest thing to do? I don't see you guessing. Let me tell you. We go to the calculator and go back to the calculator menu. What calculator should I use? It's not 13. It's not 13 because the survey question is, how much money do you make? It's not a yes or no question. And so it's not about proportions. So it's very important to identify whether you have a yes, no question or a quantitative question. And the survey question is how much money you make. And you might make $85 an hour. I have no idea what nurses exactly make, but that's not a proportion. So which number? Let's see you jump in. Yeah, half of it, right? So what calculator number should we use? Okay, I don't see. We want a sample size because it's a how many nurses must you survey, and it's quantitative, so it's sample size for a mean. Any questions on that? It's very important you get the right calculator or things go wrong really badly. And then it asks you, what is sigma? So we're going to use sigma, which they gave us as 25. It asks you for E, we want a margin of error of 50 cents or 0.5. So E is 0.5. And CL is a confidence level. And we want to be 95% confident. So 0.95. And we hit calculate. So in order to have a margin of error of no more than 50 cents, then we should survey 9,604 nurses. Okay, that's a lot, by the way. Okay, you might say, I can't do that. So you have a choice. You can change the confidence level, or you can change the margin of error. You can't change sigma. If you decided to be $1 instead, if you decided to be $1 instead of 50 cents off, that cuts it a lot. 2,401. Still pretty many, but not nearly as many. Cuts it by a factor of 4. Any questions on that? Okay, so, and again, if you're okay being 90% instead of 95%, then you only have 1,691 people to survey. So there's all these gives and takes. If you are okay with having a lower level of confidence, then you need to ask fewer people. If you're okay with a higher margin of error, you can ask fewer people. And it really depends on two things. One, how much time and energy or money you have to do the survey. And the other is how disastrous it will be if you get it wrong. Does that make sense? Any questions on that? Any questions? I do want to give you kind of a heads up. I had some faculty at other colleges really mad at me for making this calculator. Any guess on why? A calculator like this had never been made before. And someone got mad at me. Okay, and by the way, it's a correct calculator. It doesn't give wrong answers. Yeah, they wanted students to do the heavy algebra. There's a lot of algebra to do to make this happen. And they wanted students to do the algebra, and I'm like, I'm going to make it easy for them. So hopefully, if you want to do the algebra, you can. You can go back to that formula and do algebra every time. But I made it so you can use a calculator. Okay, and this works for this example. Just a note. Okay, let's suppose we have another example. Okay, suppose that you want to find a 99% confidence interval for the population proportion of cars in the United States that are electric vehicles. Okay, that's an important thing, and it changes all the time. So you can't completely trust what happened 2 years ago because there's probably more now. Does that make sense? If you want a margin of error of no more than 3%, how many cars must you look at? So I went back to the calculator. And which calculator should we use this time? So what calculator is the right calculator for this question? To get a confidence interval for percent of cars that are electric vehicles. And it's not the same one we used. It's not sample size for a mean. Any guess on what? Which one? Okay, 12 is confidence interval for proportion. And we want to see how big a sample size we need. So it's not going to be 12. You're close. 13. Sample size for proportion. Do you see how that works? So if you want a sample size for proportion, then you got to go 13. If you want a confidence interval, but we're asked for the how many cars must you look at. And here there are two choices. There's no estimate for P, and there's have an estimate for P. It turns out when you had the sample size for standard deviation, you had to have an estimate for the standard deviation, or you can't do it. It's not possible. Turns out it is possible if you have an estimate, if you don't have an estimate for P. Okay, do we have an estimate based on part A for the proportion of all cars that are electric vehicles? Based on this information, do we have a good guess on what percent of the cars might be electric? For part A, not for part B, for part A. Okay, and the answer is no estimate at all. Okay, for part A, we don't have an estimate. Do you see that? So that means I want to make sure I have no estimate for P. Hit. Then we type in E. E is a margin of error, and that is 3%. Got to make sure you turn it into a decimal. So 0.03. Okay, confidence level. I want to be 99% confident. So confidence level will be 0.99. And hit calculate. So I need to survey or look at 1,844 cars. And then I'll have a good enough confidence interval with a small enough standard error using a 99% confidence level. Any questions on this example so far? Any questions? Okay, so next, now we'll go to part B. Let's suppose you looked at last year's data. And last year, 2.2% of all cars were EV. Okay, not a huge percent, but I don't know, I looked it up and that's what it said. How many cars would you need to look at for the 99% interval? Okay, we still want a margin of error of no more than 3%, by the way. So what changes now in this calculator? It's still proportion, so I'm in the right calculator. I still want a confidence interval. Yeah, now we have an estimate for P. So now I'm going to click have an estimate for P. And now you'll see it jumps in and asks you, what is that estimate? Is that clear? And our estimate was 2.2%. Do not type in 2.2. What should I type in? So this would be wrong, 2.2. That's not right. What do I have to type in? Not 2 either. Because these are common mistakes. That's why I'm kind of going over and seeing if you can guess or see it. Okay, it's 2.2%. You need to turn that into a proportion. And you find a proportion by moving the decimal over 2 places. 2.2% is 0.022. Is that clear? Any questions on that? Okay, then we're going to use the same margin of error and the same confidence level. Okay, by the way, the good thing is I've been teaching this a long time, so I've learned where people make mistakes. So I try to like overemphasize the things that will help you not make that mistake. Doesn't mean you can't make other mistakes, but that's like a classic mistake, is to not turn your percent into a proportion. It's real common. And hit calculate N. Notice it is much smaller. 159. So the other, if you remember, so this is 159. And the other, if you remember, I got no estimate for P. That was 1844. It made a huge difference having that. And it turns out if your estimate is a very low percent or a very high percent, it changes the sample size by a lot. It turns out, and again, the math is really hard, so I'm not going to get into the details. It turns out that what the calculator does when there's no estimate is it automatically chooses 50% as the estimate. And 2.2% is really far from 50%. So it makes a big difference. Whereas if your estimate was, say, 49%, it's not going to change much of anything. Okay, and again, there's math involved, but it involves calculus, which I'm not doing, but you can trust me. Any questions at all on this example of finding the sample size that's needed for a proportion? Any questions? Okay, so again, confidence intervals happen a lot. Okay, a lot of times people will say that, here's my best guess for the percent, but I might be off by a couple percent. Okay, in fact, one of the places that it happened, and I actually posted it as my sample post on the discussion board. What's the other big thing? It's not happening this month, but first week of next month, the big thing that's like half of the news right now. What's the big thing in the news? The election. Okay. And it turns out, and this is a little weird, that we don't know who's going to win, Trump or Harris. They've done lots of surveys, lots of polls. And if you look at the confidence interval for the percentage of people that are going to vote for Trump, it's like 0.47 to 0.53, which means that if it's on the low side, he loses. If it's on the high side, he wins. So right now, we really don't know. And that is rare, by the way. Okay, and in fact, I will let you know what I usually do this time of year is I look at it and I look at the confidence interval, and if the person who, if there's one of the people running has a confidence interval that is all over 50% or all under 50%, then I know who's going to win. Do you know what I do at that point? Besides teach it? Any guess? Gonna kind of show you a reason. I bet, and I bet on the stock market. Okay. So I bet in the stock market and I buy stock that is going to do well when that person wins for the president. And I have made a lot of money that way, by the way. Okay, and it works really well. Unfortunately for me, is that I don't know who's going to win. It's weird. I've been watching all the surveys, and if you look at the margin of error, and you look at the confidence interval, both of them have 50% inside that confidence interval, which means it could be on either side. So unfortunately, I don't know what to buy right now in terms of stock. Okay, I use statistics a lot for making money, by the way, in the stock market. Okay, and that's one is I use it for that, but right now I don't know who's going to win because they both have 50% within their confidence interval, and that means that it could be either way. Okay, any questions on that idea? I like to give you like real applications, and for me, maybe you don't want to make money, but hey, I make money. I've made a lot of money when there is where it is clear. Okay, just let you know that. So we have done what we need to do. And the secret word is many. Okay, so the secret word for this webinar is many. Okay, and the word for many, the reason, is in the template. If many samples of size whatever are taken, that was part of the template for the confidence level interpretation, is that word many happened. Okay, so that's about it. As I promised, today's a bit shorter than usual, but not super short. But um, I am going to stop the recording. So thanks for coming, by the way. You saved the day. And what I'm going to do is remind you if you come next week, that helps a lot because then we'll have enough people. And usually I have more than one, but not this quarter for some reason. I don't get a lot of people. Okay, so I am going to stop the recording.